The next service in terms of processing stage is the plate detection service. The plate detection service subscribes to a queue which receives events from the FTP service. This service relies on a deep neural network for the detection of number plates and expects these arguments to be provided, which are the path to the model containing the deep neural network weights. The labels for our models and the model I'm using, it just contains one label, so there's going to be one label normally all the time, and a configuration file which contains certain other things. So the content of the configuration file is like this. We have on top level a development configuration and a production configuration. So when we are running locally for development purposes, this configuration is being used. When we are running this as a Docker service, this configuration is used. So you can see the difference between the name of the host where RabbitMQ is running as being broker in the production and localhost as in development. One important aspect is that the detection stage takes into account images of this height and width. So it will always expect to find number plates in images of this size. Once again, this is related to the deep neural network, which I will cover later in another session, as well as the grayscale flag, which is set to false. So it will try to process the incoming images as RGB images, and those images need to contain 3 channels, R, G, and B, even though if they are grayscale in nature. Coming back to the code, just like the FTP service, there is a signal handler to handle control C and signal interrupt and other events for a graceful exit. And like I described before, we have reading of the configuration file by referring to an environment variable if it's production or development, loading the associated configuration data, and then just starting a loop for the plate detector. So the plate detector class itself, it's a very straightforward class. We have a consumer that reads from the RabbitMQ queue for the incoming number plates, incoming images of cars or images containing plates. There are a couple of flags, a couple of parameters we need to provide, such as if it's running in consumer mode or not. There's a publisher which we use to publish information back to RabbitMQ. We'll talk about this class in a couple of minutes. It's part of the shared code base and it's found under shared and AMQP. So after we have created a plate detector is a reference to a class which executes the deep neural network code to find the plates, a consumer which reads from RabbitMQ, and a publisher that publishes to RabbitMQ. We come to this loop forever function, which is called by the main function. So we just start the threads and then we wait for the incoming images. So once the image is queued, like as you can see by the name of this function, this means we found a new message published by the FTP service. The message content is in JSON, so we load the JSON. We find the location of the disk path of the image. We try to load it, and we try to read some basic information regarding the image. After that, we convert the image into the required format we need to provide to the neural network to process the data, and we also specify the height and width of the data to be processed. Finally, we call the function to detect the plate, and we update the message with the detections, and we update the database accordingly with the detected number plates. And finally, we publish this updated message back to RabbitMQ on a new exchange. This message is going to be read by the classification service, which I'm going to talk about in a couple of minutes. But let's take a brief look into the detect plate function on what it does. So the detect plate function takes image data and the original shape, and it tries to call the neural network code over here. All right, and then it tries to translate back the detected boxes into the original image dimensions. This is necessary because we scale the image to a lower resolution if it does not comply with the required size, which is mostly the case because the cameras usually capture the images in HD or full HD configuration, and the neural networks, they really don't need a full HD image to find a number plate in the image. So that's about it. The only remaining function is the update DB function, where we just connect to the database and we try to find the existing document that was inserted by the FTP service, and we just update this document with the new contents, which are essentially the number plate detection data.